Hi, this is Lab 4. This time we're going to talk about spring mass system. And here is the situation that we're going to study. I've analyzed this motion using tracker. Here, the origin is the attachment point of the spring. The y-axis points up and the x-axis points to the right. Before we go into the details, we'll take a moment to find out what the relaxed length and the stiffness of the spring are. And as for the spring stiffness, K sub S, we can get this one easily if we know T, the period on which the spring's motion repeats itself. And we can get this one easily from tracker if we can compute the average of all these periods here. And here's how I compute K sub S. As for the relaxed length, we can compute it if we know F sub S, the spring force. And we do, because in the beginning, the spring and the mass are motionless, so the net force must be equal to 0. And if we take the mass as our system and determine the forces acting on it, we find one contact force, the spring force, and one force acting at a distance, the weight force. So for this situation, this equation is true and we can compute L0, the relaxed length of the spring. Now, let's take a moment to look at the fundamental principles that we're going to use. First, Newton's second law. This is a fundamental principle we're using to predict the motion of the system. And these are the two forms I'm using in this lab. Second, the energy principle. This deals with transferring energy from and to the system. This is how it looks like. And if we consider the spring and the mass to be the system, and assuming that air resistance is negligible and there's no work done near the attachment point, that means that there's no energy transfer between the system and the surroundings. So delta E equals 0 and the work must also be equal to 0. And we know that W is equal to K plus U sub S plus U sub G. You should notice that in this lab we're not going to make any predictions using the energy principle, but we're going to use energy graphs to help us understand what's happening with the kinetic energy and potential energy of the system using these relations. Now let's see what changes should we make to the computer model to have it work correctly. First, the initial conditions. The mass of the object, the position as we got from tracker, the velocity is 0 as it was released from rest, and T is the time we choose to start our clock. These lines are set to read the CSV data that we got from tracker. Delta T, this should be small enough compared to 9 seconds, and this value is okay. G stands for gravity, K sub S, the spring stiffness that we computed earlier. L naught, the relaxed length. These two lines are used to compute the vector L and the unit vector L hat, and this line computes S, the displacement of the spring. These lines are to compute the energy that we expressed earlier. This loop is used to predict the motion and update the graphs. Here we set the initial kinetic energy and potential energy. Here we set Newton's second law to predict the motion. These lines are to update the stages of the spring. These lines are to update the energy changes so the computer can draw the energy graphs. These lines are to set the arrows of the gravitational force and the spring force. Now let's run the program and see what happens. Here's what happens. The blue ball represents the modeling motion, and the red ball represents the CSV data that was extracted from tracker. And we see that the two balls are moving in the same trajectory. But if we look at the graphs, we see that they're not the same. And the reason why this happens, in the real world, air resistance takes place. But in this model, we neglected it. So let's go back to the program to replace this graph with the energy graphs. First, we're going to need to edit this lines and make it full graphs. We're going to edit this line to show this graph and edit this line to hide this graph, and run the program and see what happens this time. Here's what happens. These are the energy graphs. The green graph represents the kinetic energy. The blue graph represents the spring potential energy, and the red graph represents the gravitational potential energy. And all these three graphs add up to give the yellow graph, the total energy change. And we can see that this is wiggling up and down near zero. And the reason why this happens is what we're going to discuss in what does it mean question. Let's take a look at this question for a remodeled system.